All right, guys. Modeling and optimization. Example 1A. What is the largest possible area for a right triangle? Whoops, I need a pen. And with having the hypotenuse is 5 centimeters long, and also find the dimension. So let's draw out a right triangle. Right now, we only know one thing, 5 centimeters squared belong to hypotenuse. Okay, so we want to look for the biggest area. So area of a triangle equals 1/2 base times height. So I better go label base and I better go label height. Well, as you can see right here, we do not have enough information to find the dimensions or the biggest area. So just to remind you guys, we kind of studied this already in first semester using algebra, but this time we're going to use calculus to solve, okay? So you have to rewrite the area with respect to base or with respect to height. That's really a personal choice. I'm going to pick B, and guys, it does not matter, okay? That means I need to substitute H with something. Well, where do you think that something's going to come from? From the right triangle over here. We are going to use Pythagorean Theorem to find what H is. So A squared, which is H squared, plus B squared equals 5 squared, which is 25. I'm trying to solve for H, okay? So I can substitute in here. So that's going to be H squared equals 25 minus B squared. Take the square root. And normally, students, I'm going to say, oh, don't forget plus or minus. But because H is going to be your height, we cannot have a negative height. So we were only going to be taking the positive side of it. Well, you guys have been studying how to find min and max, okay, since 4.1. And so this is really what we're doing. We're going to try to find the absolute max. And to do that, we are going to take the first derivative, okay? Oops, that doesn't look very neat. So let me write it again. A prime with respect to B. So 1/2 B, that's my U. So derivative of U is 1/2. And then copy V over. Then I'm going to now take the derivative of V, which is 1/2 times 25 minus B squared to the negative half times the inner derivative prime. So that's going to be negative 2B. And then now I'm just going to copy down my U, which is 1/2 B. All right. So let's make this a little bit prettier. This is 1/2. Okay, on the numerator, I have 25. So 25 minus B squared. Over here, what can I do? Reduce that a bit and then multiply that out to that out. So on the top, the numerator, I'm going to have a negative B squared 1/2. I'm going to put the 2 in the denominator. I have a negative exponent. I'm going to rewrite it just like that. And remember, we're about to set this equal to 0. So we want to find the common denominator. So I'm going to go in here and multiply this by 25 minus B squared. And what we do to the numerator, we are going to do to the denominator. So this is going to get set equal to 0 after I write my pretty denominator out. Okay. All right, on the numerator, I now have 25 minus B squared because the two radicals cancel each other out, and then bring over the B squared. This is going to be 25 minus 2B squared all over 2 times square root of 25 minus B squared. We're trying to find the critical points. So the critical point is when the derivative does not exist. We can see that there's a denominator, so let's solve for that. We know that the denominator cannot be 0 or negative since it is on the denominator and under the square root. So 25 equals B squared. Now, guys, normally, again, we're going to take the square root, right? And, oops, square root, not square root. We're going to take the square root. And so that's normally I'm going to say, okay, well, plus or minus 5. Now, I'm going to make plus or minus 5, but we also have to be mindful of application, right? In application, would you agree that I can't have negative height or base? So what you want to do is in the little bit, we'll cut off from 0 and higher. But right now, you guys know I cannot have negative 5 or 5 because that would make the denominator 0. But when I plug in like 2, 3, 4, 5, right? Well, 5 can't have, but 2, 3, 4, that's going to give me positive under the radical. So I'm okay to have that. Now, when I plug in 100, that's negative and negative, so I can't have it. But just be mindful here. Remember, we can't have, okay, a base of 0 because we can't make a triangle. We can't have base of a negative measurement because we can't make a triangle. So students, right now, your domain of this base is non-inclusive from 0 all the way to 5. So just be more cautious when it comes to an application. Okay, so now that's the denominator. Let's go and look for the numerator. Numerator is going to be take 25 minus 2b squared equals to 0. 25 equals 2b squared, divide both sides by 2. So now take the square root, and again, we normally would have plus or minus if it is not an application, but since it is, we would only need the positive side of that. Okay, so I have two critical points, 5 divided by rad 2 and positive 5. Let's make a number line to see where we are going. Okay, this is f prime of the base. We can only have, okay, here's 0, here's 5 divided by rad 2, and here's 5. We can't have anything less than 0. Okay, I'm only picking positive base here. Okay, guys, so since we cannot have anything on the negative side because that would represent negative value for base, can't have anything over here on the right side of 5 because then that would make this denominator 0. So technically I would only have f prime. I only have one value in between 0 and 5 rad 2 to pick. Let's pick 1. And one value in between 5 rad 2 and 5 to pick. So let's pick 4 to see if these will give us positive and negative. Plug it into our first derivative. Where would that be? Here. Let's pick this, okay? On the top, when I pick 1, that would be positive divided by. On the bottom, when I pick 1, that would also be positive, so that is positive. Now, when I picked 4, 4 squared is 16 times 2, okay, 25 minus 32, that's negative on the top. 4, that's going to be positive, so now this is negative. Okay, so how do we know? Let's confirm, even though the question already told us that we are going to look for the maximum, but let's confirm to see if this is actually, if our work is correct, right? Do you guys remember that L max is when the derivative goes from positive to negative? Okay, well, that is confirming this. See how the derivative changes from positive to negative? So we know for sure the absolute max, okay, is going to be 5 divided by rad 2. But now we have to plug it back in to get our answer. So ready? A of 5 divided by square root of 2 equals 1/2 times 5 divided by square root of 2 under the square root. 25 divided by 5 divided by rad 2 squared, so that's 25 over 2. Okay, so let's see what my largest area is. We are going to have 1. So 5 over 2 rad 2 under the square root. I'm going to make this into a 2. So this is now a 50. That's going to be 25 over 2 under the square root. Then this is going to give me 5 rad 2 times 5 over rad 2. And so that's 25 over 2 times 2. So that's 25 over 4, y'all. 25 over 4 is the largest area, and we're going to write centimeters squared. I'm going to write one complete sentence at the bottom. We know the base. We found the base at, okay, so b equals 5 over rad 2. Leave it inexact. Now we just have to plug it in to get the height. Whoa, that is funky. Come on. All right, oh, there you go. Okay, so I'm going to come over here and plug it in to get our height. Height equals 25 minus 5 divided by 2 squared. So that's going to be 25 all over 2. Common denominator, that's 50. So h equals square root 25 over 2, which is 5 over 2. Oh, look at that. H and base are the same. Okay, so here we go. The largest area is 25 over 4 centimeters square with dimensions of 5.2 centimeters by 5.2 centimeters. All right, guys. All right, guys. So 1b says, what is the largest possible area for a rectangle whose perimeter is 8 meters, and what are its dimensions? And again, very similar to 1a, except now you just have a rectangle. So students, I am not going to solve this all the way for you. I will set you up. Largest possible area. So you are going to start with an area formula, which is base times height. Base, height, and you can use any variable you want, okay? You have a perimeter of 8 meters. So perimeter is 8 meters. All right, and we're looking for dimensions in addition to the largest area. So I'm going to write the largest area is, you fill this in after you do your work, and I think it's meters square with the dimensions of blank centimeters, nope, meters, my bad, blank meters by blank meters, okay? That's your job to fill out in a little bit. So what should you do? Similar to example 1a. You want to start with area equals base times height, rewrite it with one input. So let's say you pick b, and no, it doesn't matter. Then you're going to keep b here and substitute h. Where are you going to get your h? Well, from the perimeters over here. So you got 8 meters for its perimeter. Well, perimeter of your rectangle is 2 base plus 2h. So now do me a favor, solve for h, substitute in, okay? Then I want you to use first derivative to see if you can find your absolute max. And then once you have that, do some basic math and then fill in your answer below.